Hi everyone, I'm Abdur Rahman. My topic is radioactivity, definitions and its types and losses of radioactivity decay. Now we can see line by line what it is. Now we will see what is radioactivity. So it is a spontaneous emission, right? So in that property possessed by some elements such as uranium or isotopes as this carbon 14 is spontaneously emitting, right? It is in energetic particles such as electrons or alpha particles. It is by the disintegration of what? Disintegration of nucleus or disintegration of nucleus is called radioactivity. So in simple we can say emission of ionization radiation or particles caused by the spontaneous disintegration of atom nucleus called as radioactivity. So substance radiation by this escape of radioactivity. Now let me see first types of radioactivity. There are four major types of radiation, that is alpha, beta, neutrons and electromagnetic waves like such as gamma rays. Okay, it is differ in mass, energy and how deeply they penetrate the people and objects. Okay, as I said before, there is mass energy is differ. See, the mass energy will differ, right? So in alpha, beta, gamma, neutron, the energy will be differ. And then these are the major types, that is alpha, beta, neutrons and gamma rays. The first is alpha particle. Okay, these particle consists of two protons and two neutrons. Okay, it is heaviest type of radiation particle, and it is like many of naturally occurring radioactive materials in the earth like uranium, thorium, and it emits alpha particle. Okay, the best example of alpha particle is the people most are familiar with the radar in our phones. Okay, the second is beta particle. Okay, it is an electron that is not in an atom, right? So it has small and negative charges, that is tritium. Okay, which is produced by that which is produced by cosmic radiation in the atmosphere. What is cosmic radiation in the atmosphere? It exits all around us. Finally it emits like beta radiation. Okay, the best is carbon 14. It is used in carbon dating of fossils, and all other like artifacts is also emits beta particles. Okay, uh, in that case, but carbon dating is simply makes the use of fact that carbon 14 is it's like radioactive, and if you measure the beta particles, it tells you how much carbon like 14 is left in the fossil. Okay, which allows to calculate how long ago the organism was alive. The third is neutron. It is a particle that does not have any charge and is present in the nucleus of an atom. Right. So the neutrons are commonly seen in uranium. Okay, in an atom split or fission. It is in the nuclear reactor. Basically, the atoms is split in the nuclear reactor. Right. If it was not for the neutrons, so you will not be able to sustain the nuclear reaction to use generate power, right? So in the basically the atoms is present in nuclear as of an atom, right? So what I said, it does not have a charge, but in nuclear reaction they will generate the power. So the last kind of reaction like electromagnetic radiation, that is X-rays and gamma rays. Okay, it is probably the most familiar type of radiation. Okay, because it is used in widely medical treatments. Okay, these rays are like sunlight except they will have like more energy. Okay, so unlike the other kinds of radiation, there is no mass and no charge in it. So this amount of energy that can be, the range will be very low and in dental rays, and to very high levels seen in irrigators. Irrigators is nothing but it sterilize the medical equipment which is used for sterilize the medical equipment. So as mentioned, these different kinds of radiation, it travels a different distance and different abilities to penetrate and depending on their masses and their energy. The figure right shows the differences of neutron because they don't have any charge and don't react with materials very well, and it will go a very long way. So the only way to stop them is large quantities of water or other materials made by very light atoms. Okay, so in that case, on the other hand, that is alpha particle. Okay, it because of very heavy, because of it's very heavy and has very large charge, but it doesn't go very far at all. Okay, so in that case, it means alpha particles can't even get through a sheet of paper also, right? So the alpha particle is outside in our body, in your body, like it only penetrate to surface of the skin, right? So in that case, the inhaling or ingest of material, it emits alpha particle. It is sensitive to issue like lungs can be exposed some, yeah. This is why high levels of radon are considered as a problem in your home. Okay, so the ability to stop alpha particles is so easy to useful in smoke, like detectors, because it smokes like in chamber is enough to stop the alpha particles and trigger the alarm also. Now, to be useful in medicals imagining, so it is in beta particles must be released in materials that is injected in the body, right? So it can also be very useful in cancer therapy. If you can put the radioactivity material in tumor, it is gamma rays and X-rays can be penetrated, like through the body, right? So this is why they are useful in medicine to show whether bones are broken or whether it's tooth decay or it is located as tumor. So here you can see the picture some of the beta rays like X-rays and then some gamma rays also. So here a best example of technician that is does not he does like your dental x-rays. It will he used to put like apron over you because you want to be safe to while taking the picture, right? So it is a real example of gamma rays. So in the wavelength of gamma rays is less than 100 picometers. Okay, and the frequency is greater, about 10 power 19 hertz. Now, finally, the loss of radioactivity in decay. So, when a radioactivity material like undergoes like alpha, beta, and gamma rays decay, if the number of nucleus undergoing to the decay per unit time is proportional to the number of nuclei. In sample material, we can say that these are just you just see the diagram here. Uh, two pro two protons and two neutrons in alpha radiation, right? So and in high energy in beta radiation, but in nucleus of an atom, it doesn't have charge, but there are three types of radiation in decay. That is gamma rays is reflecting here as well, but it is high energy in electromagnetic proton, right? So in that case, some numericals which I solved here of loss of radio decay. So in that case, finally we are getting n t is equals to n naught e power minus lambda t. Okay, e power minus lambda t. Okay, these are the fourth equation is the loss of electroactivity decay. Thank you guys. Subscribe my channel. I'll see you in next video. Bye bye. Take care.